Hi friends, I am Shivtej Patil. Today we learn about the most important topic in mathematics which name has Bernoulli's equation. Okay. The Bernoulli's equation is always used in study of mathematics in engineering level or senior level. Okay. So before learning the Bernoulli's equation or the definition of Bernoulli's equation, we have to know the linear differential equation concept, because the linear differential equation is the base of Bernoulli's equation. It is exactly as of the form of linear differential equation in order first. Okay, so for learning Bernoulli's equation, we have to know the linear differential equation and its concept. Okay, before learning the Bernoulli's equation, firstly we see the linear differential equation and what type of concept used for linear differential equation exactly used as for Bernoulli's equation. Okay, firstly we see linear differential equation. Now here first we see the exact linear differential equation for first order. Okay, here we take LDE for order first. In order first, linear differential equation has the form here. The form of equation is, what is the form of linear differential equation in first order? It has dy by dx plus py is equal to q. Okay, here y is dependent variable, and it have the power is 1, and dy by dx, here the derivative of y has power 1. Okay, therefore it is the linear differential equation. And here capital P, that capital P and that capital Q are functions of x only. In that equation we see that here we take derivative of y with respect to x, therefore P and Q are the function of x only. And today only we take as dy by dx, so P and Q are a function of x only, otherwise here we take y. Okay, but today we see dy by dx only related to x. Okay, now what is here for the solution of LDE? We use integrating factor. What is the integrating factor? Which is equal to e raised to integral over p dx, that p and the p and q are related to x, therefore here we take dx. Okay, now what is the solution of that equation? Solution is firstly we take that y dependent variable into take integrating factor is equal to integral over, we take q, then into take integrating factor, here we take dx because p and q are related to dx or x, plus constant c. Therefore the solution of that linear differential equation in first order is y into integrating factor is equal to integral over q into integrating factor dx plus c. Okay, this is the exact method for solution of linear differential equation. Now exactly we see here Bernoulli's equation, what type are taken in that definition. Okay, exactly this method is used in Bernoulli's equation, but there is some another construction in that definition. Firstly we see that in Bernoulli's equation the equation has form The equation has form. What type of form of Bernoulli's equation? Here we see that dy by dx as it is, dy by dx as it is, plus py as it is, okay, is equal to q. But here we take some another quantity which name as y raised to n, okay. The form of Bernoulli's equation is dy by dx plus py is equal to q into y raised to n, okay. It is exactly as the linear differential equation in first order, but here the adjacent term is y raised to n, okay. Now we take that form of equation. Here that capital P and capital Q are functions of x only, okay. There are functions of x only, therefore here we take dy by dx, derivative of y with respect to x, therefore p and q are the functions of x only, okay. Now for solution of that Bernoulli's equation, that is the Bernoulli's equation form, but here we have to find the solution of that equation. For taking solution of that equation, here we construct some reducing or different type of method for reduce that y raised to n. If we reduce that y raised to n, then we will get the solution of Bernoulli's equation. Firstly, we reduce the y raised to n, okay. So firstly here we give the equation 1 for that equation. Now for finding solution of Bernoulli's equation, we take some terms in reducing, okay. We reduce the term y raised to n or eliminate that, okay. We eliminate y raised to n. For eliminating y raised to n, here we take as that equation, take as it is dy by dx plus py is equal to q into y raised to n as it is take. Now for eliminating that y raised to n, we divide the y raised to n on both sides. Divide y raised to n on both sides. Then here we take 1 upon y raised to n into dy by dx, okay, plus py taken as it is upon y raised to n is equal to q into y raised to n upon y raised to n, okay. Taking both side in upon y raised to n for eliminating that y raised to n, we have to find the solution of that equation, okay. Now here we take as that values are 1 upon y raised to n dy by dx, okay, plus py upon y raised to n is equal to q y raised to n upon y raised to n, okay. Here we see that y raised to n, it will become in numerator, then it will be become as y raised to minus n dy by dx, okay, plus as it is that y raised to n will be come in numerator, then it will be become py as it is taken, and y raised to n will be become into y raised to minus n, okay, which is equal to that q as it is, and y raised to n and y raised to n will be cancelled, okay. Now here we see that y raised to minus n dy by dx take as it is, plus, but here p take as it is, y into y raised to minus n, it will be written as y raised to 1 into y raised to minus n, okay, is equal to q. Then it will be become, using property of power, y raised to minus n as it is, dy by dx take as it is, plus here we take p into y raised to 1 into y raised to minus n, it will be become as y raised to 1 minus n is equal to q, okay. Now here we see that equation will be in that form. Now here we take some substitution in that equation, okay. Put that y raised to 1 minus n, that y raised to 1 minus n will be take as small letter u, okay. Put u is equal to y raised to 1 minus n, then it will be become as equation y raised to minus n dy by dx plus p into u is equal to q. That will be equation become equation 2, okay. Now y raised to minus n dy by dx plus p into u is equal to q, which is equation 2. Now here we take the derivative of u. Here we take u, small u. What is the value of small u? Y raised to 1 minus n, okay. Now we take derivative, then it will be become as, with respect to x, du by dx is equal to, what will be become as d by dx of y raised to 1 minus n, okay, y raised to 1 minus n, then it will be become as du by dx is equal to that 1 minus n power into y raised to that 1 minus n minus 1, okay. But there is the function or variable is y, therefore here we take dy by dx, okay. Now again here we see that, here we firstly erase that will be become as du by dx is equal to, it will be become 1 minus n into y raised to 1 minus n into y raised to that 1 and minus 1 will be cancelled, y raised to minus n dy by dx, okay. Now that 1 minus n, it will be become in the outside of du by dx, it will be become as 1 upon 1 minus n du by dx is equal to y raised to minus n dy by dx. Now y raised to minus n dy by dx, that is the value in equation 2, okay, y raised to minus n dy by dx, then that value will be put in that equation, therefore equation 2 becomes, put y raised to minus n dy by dx is equal to 1 upon 1 minus n du by dx in equation 2, okay. Then equation 2 becomes what type of equation become as that 1 upon 1 minus n du by dx put in that value, therefore 1 upon 1 minus n du by dx plus pu is equal to q, okay. Now 1 upon 1 minus n du by dx plus pu is equal to q. Exactly here we see that the equation in almost become in the variable u, which is dependent variable, okay, which is dependent u and u, but here we take the coefficient 1. For taking coefficient 1, that 1 minus n will be multiplied on both sides, okay. So 1 minus n, okay, 1 minus n multiply on both sides, then it will be become as du by dx as it is. That 1 minus 1 will be cancelled. Here take 1 minus 1 plus 1 minus n into pu, okay, into pu is equal to q into 1 minus n, okay. 1 minus n will be here be multiplied, therefore that upon 1 minus n will be cancelled, and here take 1 minus 1 and here take 1 minus 1, okay, then it will be become as 1 minus n, okay. Therefore will be here we have the equation as du by dx plus 1 minus n into pu is equal to q into 1 minus n. It will be become as the linear differential equation in the form of u, or in the variable of dependent variable of u. Then it will be have the solution. Therefore solution of the Bernoulli's equation is, what is the solution of that equation? Firstly we take the dependent variable u, okay, exactly it is as the linear differential equation, okay. Therefore take dependent variable u into integrating factor is equal to integral over, that will be q as it is, and into integrating factor dx plus c, okay. Then it will be become the solution of Bernoulli's equation in the form of LDE, okay. Firstly we take the Bernoulli's equation in the part dy by dx plus py is equal to q into y raised to n, then it will be become in du by dx plus 1 minus n into pu is equal to q into 1 minus n in that form, and that will be the linear differential equation in dependent variable u, and it have the solution as LDE, which as u into integrating factor is equal to integral over q into integrating factor dx plus c. Here we take Im as Im is equal to e raised to integral over here we take the p function p dx, okay. That is the overall solution of Bernoulli's equation. So today we see the Bernoulli's equation have the solution of type LDE. So firstly we revise the LDE and then take the solution of Bernoulli's equation, okay. Now let us here we stop here, because the Bernoulli's equation will be exactly we take in our mind, okay. So stop here and thank you very much.